Let's look at solving a few more quadratic equations. This time we'll include ones that may have complex roots, but that means that we should also look at a few examples just involving complex numbers. This first example, we are multiplying negative 3 plus I times 3 plus I, and we're going to distribute just like we would if we were multiplying two binomials. So negative 3 times 3 is negative 9. Negative 3 times I is negative 3i. I times 3 is 3i. And I times I is I squared. We can combine like terms. And here our negative 3i and our positive 3i will combine and cancel out. And we'll be left with negative 9 plus I squared. Now you need to remember what I equals. Remember, I is defined as the square root of negative 1. So I squared equals the square root of negative 1 squared, which is negative 1. So now I can go back and replace my I squared with negative 1 and get negative 9 plus negative 1, which is equal to negative 10. So that is our product here. Okay, let's look at a division problem. Here we are dividing 10 by 3 minus 4i. So with complex numbers, in order to divide, we will end up multiplying using the complex conjugate. Or the complex conjugate of the denominator. So in the denominator, we have 3 minus 4i. The conjugate will have the same terms, but the opposite or inverse operation in between the terms. So here, since we had 3 minus 4i, our complex conjugate will be 3 plus 4i. Same terms, 3 and 4i, but instead of the minus, we have a plus. So now we're going to take our original problem and multiply by a fraction where that complex conjugate is in the numerator and the denominator. And we will multiply the numerators and multiply the denominators. When we multiply the numerators, and having parentheses is needed, we will get 10 times 3 is 30. 10 times 4i is plus 40i. We'll multiply the denominators. 3 times 3 is 9. 3 times 4i is 12i. Negative 4i times 3 is negative 12i. And negative 4i times 4i is minus 16i squared. So we're going to simplify the denominator. We can combine like terms. The numerator will stay the same. 30 plus 4i over 9 minus 16i squared, because the 12i minus 12i cancel out. Okay, but remember, we need to replace our I squared with negative 1. My numerator will stay as 30 plus 40i, and in the denominator I now have 9 minus 16 times negative 1, or 30 plus 4i over 9 plus 16. And this further becomes 30 plus 4i over 25. Now this is essentially our answer, but complex numbers are usually in the form a plus bi. So let's put this expression in that form. And I can do that by separating this into two fractions. 30 over 25 plus, because we had a plus in the numerator, 40i over 25. And let's simplify these fractions. 30 over 25 becomes 6 over 5. And 40 over 25 becomes 8 over 5. And we have our I. So 6/5 plus 8/5 I is our solution. Okay, let's get back to solving quadratic equations. Here we have x squared plus 25 equals 0. Now I could solve this using completing the square or quadratic formula, but because this does not have a b term, our b is 0, we could solve it by using square roots. So because we have no b term, I can move my c term to the right-hand side. So I have x squared equals negative 25, and we will take the square root of both sides. So on the left side, I have x. On the right side, I will have plus or minus the square root of negative 25. Remember, whenever you're taking the square root of both sides of an equation in the process of solving it, you will have a plus or minus. Now we need to simplify the square root of negative 25. I can separate out the square root of negative 1 because the square root of negative 1 times the square root of 25 gives us the square root of negative 25. So I can separate out that square root of negative 1. And the square root of negative 1 is equal to I. So this can simplify to plus or minus I times the square root of 25. What is the square root of 25? 5. So this becomes plus or minus 5i. Those are my two solutions. Okay, let's look at another equation. X squared plus 4x plus 8 equals 0. So here a is 1, b is 4, c is 8. Let's use our quadratic formula, substituting in the opposite. So x is equal to the opposite of 4 plus or minus the square root of 4 squared minus 4 times 1 times 8 all over 2 times 1. Let's simplify. So negative 4 plus or minus the square root of 16 minus 32 all over 2. Simplifying underneath the radical. Negative 4 plus or minus the square root of negative 16 all over 2. Now we need to simplify the square root of negative 16. I can take out my square root of negative 1, which is equal to I. So I radical 16. What is the square root of 16? 4. So this is 4i. So now, substituting that in, we have negative 4 plus or minus 4i all over 2. And let's simplify this to put it in proper complex number form. Negative 4 over 2 plus or minus 4i over 2. Negative 4 over 2 is negative 2. 4i over 2 is 2i. So I have x equals negative 2 plus or minus 2i. This is two solutions. So one solution is negative 2 plus 2i. The other solution is negative 2 minus 2i. Okay, let's look at our last example. 5x squared plus 1 equals 2x. Going to put this in standard form by subtracting 2x from both sides. 5x squared minus 2x plus 1 equals 0. A is 5. B is negative 2. C is 1. Let's use our quadratic formula again. So x equals the opposite of negative 2 plus or minus the square root of negative 2 quantity squared minus 4 times 5 times 1 all over 2 times 5. Simplifying, we get x equals 2 plus or minus the square root of 4 minus 20 all over 10. Combining the terms underneath the radical, I have 2 plus or minus the square root of negative 16 all over 10. Remember, the square root of negative 16 simplified to 4i by taking out our square root of negative 1. So we can write this as 2 plus or minus 4i over 10. Let's simplify that. 2 over 10 plus or minus 4i over 10. And if I simplify my fractions, we have 1/5 plus or minus 2/5 I. And those are my two solutions for x.